Now that we have looked at how to generate booleans using comparisons, we have a few more tools that we can use to combine these booleans into individual booleans, single booleans. And these tools are what are called logical operators. So these are just more operators like we've seen before, but instead of operating on numbers, they're going to operate on what we call logical components, in this case just booleans. So let's look at an example, and we'll use some integers for this. We'll say a equals 30, b equals 60, and c equals 90. So these are three angles in a right triangle. And we can do a lot with this, but let's just say that these are three angles of a triangle. And I can say the total angle is A plus B plus C. And I can create a Boolean called isTriangle. And isTriangle wants to know, is the total angle equal to 180? And I can say system.out.println isTriangle, and I can run that. So if I run this code, those do add up to 180, but if I am off by just one, it is false. So this is a quick and easy way to use Booleans to check one condition. So this tells me, do I have a triangle? But what if I wanted to know, do I have a right angle? And I need at least one right angle. And a way to do that is to check them. So I can say Boolean is A right, and that's going to be A equal 90. I can say Boolean is B right, and that's going to be B equal 90. And I can say Boolean is C right, and that's going to be C equal 90. And I could check all of these. But I could simplify this a little bit and just do it with one and just say, is one right angle? And I can do it with this notation. And I'll explain it in just a second. And I can print this. So everything should look about the same as we've seen before, except this line looks a little different. Right? We definitely see, okay, this looks like it's checking is A 90. This looks like it's checking is B 90. And this looks like it's checking is C 90. But then we've got this weird symbol between them, two vertical bars, or two pipe symbols. And these symbols together are the OR operator. And so if I run this code, let's see what happens. It prints true. Okay, I'm going to remove our isTriangle for a minute just so that we get the one so we can read it more easily. And we do see true. What the OR operator does is it says, I'm going to look at every condition, and if one of them is true, the whole thing will be true. So if I changed A to 31, it's still true because this is false, right? 31 is not 90. This is false. 60 is not 90. But this is true because 90 is 90. And the OR operator says at least one must be true. And the way we think about it, we have a truth table. And we'll call this the OR truth table. And there's 4 possible outcomes for 2 numbers, or for 2 situations. We'll say true or true, true or false, false or true, and false or false. And we'll fill out the table like this. So OR says at least one must be true. So if we have true or true, then the whole thing is true. And we can extend this out to 3. If at least one is true, the whole thing is true. So here, I don't care which one is 90. I just know that one of them has to be 90. And that's what we're checking here. True or false? Well, one of them is true, so it's true. False or true? One of them is true, so it's true. False or false? Neither of them are true, so the whole thing is false. All right, so if I go back to this and I were to say, okay, what about 31 and 89? So now none of these are 90. A is not 90, B is not 90, C is not 90. But if I run it, I get false. Because even though I was checking all 3 conditions, none of them were true. So we know it is not a right angle in any of them. Okay, so we'll bring back our is triangle. And we can set that equal to A plus B plus C is the same as 180. So this is checking, is there a right angle? And this is checking, is it a triangle? And the reason we're checking both of those conditions is we know that if something is a triangle and if something has a right angle, it is a right triangle. So I can say Boolean is right triangle is equal to, is it a triangle? And then this symbol is one right angle. And I can print that. And I can print it just like that. So I'll run that and I'll talk about what it means in a second. And I get false. Well, let's see what we're checking. This symbol, ampersand, ampersand, is called the AND operator. And the AND operator is another way we can combine multiple Booleans. To be a right triangle, you must both be a triangle and have one right angle. Well, we're going to break up our print statements a little bit and see what exactly is happening here. So is it a triangle? It's going to be based only on the is triangle. The has right angle is going to be based only on is one right angle. And then the is right triangle is going to be based on the is right triangle variable. So let's run that again. Okay. Is it a triangle? It is a triangle, but it is not, it does not have a right angle. And it is also not a right triangle. That's because with the AND operator, it's not at least one, it is everyone must be true. So to be a right triangle, is triangle has to be true, and is one right angle true. So if I were to change this 89 to a 90, and if we were to run the code again, It's not a triangle because 31 plus 60 plus 90 is not 180. It's more than 180. Has right angle. Well, that's true because C is 90 degrees. And again, it doesn't matter which one of these is 90 degrees. If I had swapped A and C and run that, I'm still false here and true here. And my is right triangle is false now because yes, there is a right angle, but it's not a triangle. So we're going to build up not the OR truth table, but now we're going to build up the AND truth table to make sure we understand it. So we have, instead of the two vertical bars, we have two ampersands. So the AND says everyone must be true. True and true. Both are true. True and false. Only one is true, so the whole thing is false. Remember, for AND, they all have to be true. False and true, only one of them is true, so it's false. False and false, neither of them are true, so the whole thing is false. So what's happening in the is right triangle is that if one of these is false, or both of them are false, then it is not a right triangle. And if I were to check again, 30, 60, and 90, those do add up to 180. One of them is 90 degrees, and we run it. It is a triangle because they added up to 180. There is a right angle. A is 90 degrees. So it does have a right angle. And so because it is a triangle and it has a right angle, the whole thing is true. It is a right triangle. And again, if I were to flip a couple of these around, it doesn't matter which one is the right angle, as long as one of them is, because our check for the right angle uses these ORs. Now there's a couple of things to note. There's actually two more operators like this, and they look like this. And the trick is that the single bar is also the OR operator, and the single ampersand is also the AND operator. But they behave a little bit differently. This is the short circuit OR operator, and this is the short circuit AND operator. And the trick is just a little subtle. And this takes a little bit of practice to get used to. When you short circuit, you stop as soon as you can be sure of your answer. For the ORs, remember we said for OR, there must be one true. So when OR, when you're using the two bars, when it finds one that is true, it stops. So in this case, A is 90, false. B is 90, true. Since OR only needs one of them to be true, it stops right there and it knows the answer is true. For the AND, okay, we can stop when it is false, because remember, the OR operator needs one true to be true, but the AND operator needs everything to be true. Said another way, one true makes the OR true, but one false makes the AND false. Right now in practice, you're not going to see a lot of impact from this, and it doesn't come up a whole lot when you're just starting out. But do be aware that the two vertical bars and the single vertical bar are both the OR operator, but they have a slight difference in behavior. The two ampersands and the single ampersand are both the AND operator, but they have a little bit different behavior. If you are not sure which one you want to use, you usually want to use the doubles. The short circuit ones are the ones you want to use. They're a little more efficient, and they don't rely on unintended consequences, which is something called side effects, which is something we can talk about later. But when in doubt, you want to use the doubles. Or everything is true means it's true, but just one true also means it's true. So or is looking for one true to be true. And is looking for one false to be false. It has to be all true to be true. And so that takes a little bit of getting used to, but once you practice your truth tables and play around with variables, you can make the variables do anything you want. It's good practice. The last operator is a little bit simpler, so we'll just touch on it briefly. And it uses the bang symbol by itself. It is called the not operator. And so one way we can look at this is we can say, instead of all of this, we'll just look at the is triangle. And we will say Boolean is not triangle. And we could have said A plus B plus C not equal 180. That would tell us, is this not a triangle? But the simpler way to do it is just say bang is triangle. And we can print that out. System out println is not triangle. So when we run this code, we can say, okay, 60, 90, 30, is that not a triangle? And the answer is nope, it is not a triangle. If I were to change just one of these though, and we run it again, 61, 90, 30, is that not a triangle? Yep, that's not a triangle. So the not operator is pretty simple, and it has a smaller truth table. It just has 2 rows. And the way we look at it is not true and not false. Not true becomes false, and not false becomes true. All the not operator does is flips the Boolean. So if the Boolean was false, not makes it true. If the Boolean was true, not makes it false. So these are the 3 major operators. The OR operator, where you're looking for is at least one of these true. The AND operator, where you're looking for are all of these true. And then you're looking at the NOT operator, which is just take whatever it is and invert it. If it was false, make it true. If it was true, make it false. And so it's good to kind of build some comparisons, check some comparisons, and see if you can build up some logical operators with them, chain as many as you can together, and start seeing if you can predict what the outcome is going to be. Is the overall going to be false? Is the overall going to be true? And you can do this with 2, 3, 4, 5 different conditions. You can also combine ands and ors, but that gets a little more complicated, and we're not going to talk about that right now. If you get comfortable with it and can play with it and understand it, it's great to practice, but it's not something that's going to be critical for us right now. It's going to be more important that you get used to using ors together and ands together, but not necessarily mixing and matching ands and ors right now. But this is kind of the other piece. So comparisons and logical operators are going to form the basis we need to understand conditions, which is kind of what we're building to here. So once you're comfortable with both your comparisons and your logical operators, you'll be ready to move on to talking about conditions.